Hey guys, today we're going to do 7.3. We're going to talk about square root graphs now. So we have solved square roots, and we've simplified square roots. Now we're going to graph what a square root would look like. And we've done lots of graphing before. We've done graphing lines, y equals mx plus b. We've graphed parabolas, right, the U-shaped. We've graphed absolute values, the V-shape. Well, now we're going to graph square roots, okay? What's nice about a square root is it has the same types of characteristics as a parabola and as an absolute value. If I have a square root function, there might be a number in the front of this function. There might be a number added underneath my square root, and there might be a number to the back of my square root. Those numbers are going to change my square root graph around, just like in a parabola. Those numbers change my parabola around. Those numbers change my absolute value v around. Well, they do the same thing with the square root graph. A generic square root graph kind of looks like this. It starts at 0 and it kind of goes up with a little bit of slant. For some reason, I call it a breadstick. Somebody somewhere along the line called it a breadstick and it stuck. So I call it a square root graph a breadstick graph. Okay? So it's always going to go like that. Or maybe if it's negative, it's going to go kind of like this, okay, an upside down breadstick. So we have to recall from parabolas and absolute value graphs what those numbers do, because they do the same thing with these types of graphs. So the number in the front, the A, does three things. Do you remember what those three things are? Well, the first one is slope. Not exactly a slope, but it's good enough slope for us. So if it was a 1/2 in front, we would go up 1 over 2, up 1 over 2, and kind of draw a little breadstick. Okay? The second thing that number does tells us if it opens up or down. If it's positive, your breadstick's going to go up. If it's negative, your breadstick's going to go down. Okay? The last thing it tells us is if the graph is fat or skinny. If the number in the front is a fraction, remember it's fat. If the number in the front is a whole number, then it's going to be skinny. Okay? What does the number on the inside do? Do you remember? Yep, the number on the inside moves it left or right, but opposite. Left or right, but opposite. So if it's a negative number on the inside, it's really going to move it to the right. If it's a positive number on the inside, it's really going to move it to the left. So the number on the inside moves it left or right, but opposite. And the number in the back moves my breadstick up or down. Okay? So we're doing the same type of things that we did with parabolas, just this time our graph is going to end up being one-sided instead of a parabola, a breadstick instead of a U. So here we go. Let's do a few. Here's do them with me, number 1. What I would like you to do is I would like you to graph this square root graph, and then we're going to talk about its domain and range. Okay, so let's look at the numbers of our equation and figure out what it's going to look like. What is the number in front of this equation here? Invisible 1, right? That's going to tell us the slope. What is this negative 2 going to do to my graph? It's going to move it right, correct? Right 2, because it's opposite. And the number in the back, this positive 5, is going to move my graph up 5. So let's put that all together and let's graph it. You said the 2 is going to move it to the right 2, so we're going to go right 2. The 5 is going to go up 5. 1, 2, 3, 4, 5. Let's start here. That's where my breadstick's going to start. The slope of my graph is positive 1. It's a positive, so I know my breadstick's going to go up, and it's going to go up with a slope of up 1 over 1, up 1 over 1. And then I'm just going to kind of draw a little breadstick like that. Okay? The second part of this question, though, asks for the domain and the range. We talked about domain and range before. Do you remember what domain means? It means all the x values. Okay? So on a graph, the x values are left and right. So if I'm looking at this breadstick graph, how far left on the x is this graph ever going to go? Well, it's going to start at 2, correct? Is it going to go any farther left of 2? No. Is it going to go any farther right of 2? How far right? Well, doesn't it say that this is going to keep going forever because of that arrow? So my domain is anywhere where x is greater than or equal to positive 2. Does that make sense? We started at 2 and we went all the way to the right forever. So anything that's greater than or equal to positive 2 is my domain. So then what about range? Range means all the y values. That's up and down. So on the y, how far down and how far up is your breadstick going to go? Well, it looks like it goes all the way to 5, or at least it starts at 5, right? And then it's going to go up or down from there. Well, it looks like it's going to go up. So my range is anything where y is greater than or equal to what? 5. Domain starts at 2 and goes over. Range starts at 5 and goes up. So anything that's greater than or equal to 5. Does that make sense? Let's do one more of these. Okay. Will you graph this square root graph? And then we'll talk about its domain and range. Here's my slope, negative 2. This positive 3 is really going to go left 3, 1, 2, 3, and this negative 1 is going to move me down 1. So I know my parabola is going to start at negative 3, comma 1. From there, if my slope is negative 2, how are we going to move? Down to right 1, down to right 1, and so your breadstick this time is going to kind of go like that. Okay, it's kind of a, I don't know, skinnier breadstick. I don't know, it doesn't look like skinny to me, but it's skinnier. It opens down. Let's talk about domain and range. Domain is all the x's, left and right. How far left, how far right does it go? Well, it looks to me like it goes all the way to negative 3. And then it goes to the right forever. So what do we say for that? X is greater than or equal to negative 3, because it's going to go from negative 3 over forever. Okay, what about range? Range is how far up and down on the y's. So how far, where does it start? On the y's, it looks like it starts here at negative 1, right? It starts at negative 1, and does it go up or down? Oh, this time it goes down, doesn't it? So y is less than or equal to what? Negative 1? I started at negative 1 on the y, and I went down below it, so I'm going to say y is less than or equal to negative 1 this time. Okay? You should be able to graph a square root graph. You should also be able to tell me what the domain and range is. Okay? All right. Now that we know how to graph square root graphs, what if I gave you square root inequalities? So the only difference on this question is that we have a little inequality sign here, an alligator sign. Okay? So let's graph it the same exact way. So on this graph, if I were to graph this one, where am I going to start? Well, I have a negative 4 on the inside. How does that mean I'm going to move? Positive 4? To the right? The negative 6 in the back tells me I'm going to move down 6. 1, 2, 3, 4, 5, 6. So my breadstick's going to start there. What's the slope of this graph? Positive 1, right? From the front, there's an invisible 1 there. So I'm going to go up 1, over 1, up 1, over 1. Hold on. Before I draw my line, this is where my inequality comes in. If it's a less than sign, do I want a solid line or a dashed line? We've done this before with lines, right? This time we're going to have a dashed breadstick. Because it's not an equal to, because it's just a less than, we are going to do a dashed line. We also need to do shading. If you read the equation, it says y is less than blah, 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 blah. If y is less than, which way would I shade? If we're doing y's, we're going up and down, right? So would we shade above or below if y is less than? Well, if y is less than, we're going to shade below my absolute value, or not my absolute value, but my square root graph. Okay? If y was greater than, then we would shade above. If y is less than, we're going to shade below. Got it? I'd like you to do one of these, please. Will you do this last one for me, please? Will you graph this inequality? Whoa, this one looks weird, doesn't it? Let's do it together then. We're going to ignore this 2 for right now. Okay? If that 2 wasn't there, where would we start? -1. And how far up do we go? Yeah, there's nothing on the back, right? So I'm going to go up nothing. I'm going to start here. What would my slope be? Up 1 over 1? Up 1 over 1? Solid line or dashed line? Solid line this time, right? Because of the equal to sign, I'm going to do a solid breadstick. Now I need you to shade. This says y is greater than. If y is greater than, where would you shade? You should be shading above your line. Okay? The only difference on the inequalities is your lines. Is it a solid line or a dashed line? And where are you shading? Are you shading above or below? Okay? Your homework tonight is your 7.3 worksheet. Make sure you follow the directions, graph it, state the domain and range, all that good stuff. Please behave yourselves. I'll see you tomorrow.